just to make sure we're properly safe.
For tracing purposes.
Tracing purposes and liability. Yay! So yeah. For those that need to use the bathroom, you'll go out this door, make a left at the kitchen, right? You'll exit the back doors. It'll be on your left. It is a public bathroom that's shared with Love Life, the cafe next door. If you need to, it's a one-way door, unfortunately. So you'll have to come around, and someone will let you back in again, right? Also, you know, I'm going to do it next time. Sweet, yeah, and we'll keep on going. Basically, don't be a jerk, right? Like that's all I ask. We do have a code of conduct. It applies to Slack. It applies to Meetup groups. We are serious about it, right? So don't be a jerk. Is the one word. You can go to this URL if you guys have information about that. Yeah, and then one more link. We are underwritten by Code for South Florida, which is a civic hacking. It's a civic hacking tech group. And actually, I don't actually know if we're still underwritten by that, so we'll need to check.
That's a good question.
Yeah, that's actually a great question. Because it's been so long. All right, let's go ahead, next slide. You guys may have noticed, for folks that are new here, city or otherwise, we are inside a coding school. You may have known that this coding school is Wincode. Recently, January 2020, we were required as Brain Station. Full disclosure, I work here. I am the lead educator for the web development program here. So this very room is actually used for web dev students. Full disclosure number 2, we are also hiring for educators. So if y'all are a little bit over the red, you can ask those 2 gents to the back to the right, the peanut gallery, Will and Leo. They can give you some choice opinions. Nothing but nice things. No. No. Yeah, hey, it's good. But yeah, let me know if that's something you guys are interested in. But Brain Station has generously donated both the venue and the pizza. So now that I know that they're handling the pizza, I'll order more next time. Sorry, that's no problem. One more. All right, one last thing. Who here, I just realized this, who here knows about the Slack and not the Meetup group? Raise your hand. Oh, who here knows that we have both a Slack and a Meetup group? Okay, not everyone raise their hands. So for the folks that found us out through meetup.com, welcome. We have a Slack, which is how I met Ben, right? Like that's how we're doing this. It is if you want to join it, fedm.herokuapp.com. We pride ourselves in not sucking as a community. Okay? And then for those that know us through the Slack and not the Meetup group, because I've learned that that's a thing too, feel free to join, right? That's a long link. Just find us a Google, I guess. That's good.
You just go to front end, Miami as the URL.
No, that's true. Yeah, that's true. All right. Does anyone have any like announcements or anything they want to quickly talk about before I hand it off?
Thank you.
Okay, go for it.
Hey, I don't know if you know me. My name is Riyadh. Our company is hiring a junior dev, primarily .NET. That whole NBC stack. So if somebody's interested, come find me out. Thank you.
Hey, that's all. Okay, awesome.
I have one announcement. My team's also hiring for QA/test application engineer. Probably familiar with Cypress, React testing library. So
Right on. So React testing library, Cypress. What company? If I may ask, sorry.
from Cobalt Labs.
Cobalt Labs. All right. So if anyone's interested, what was your name? I'm sorry.
Sarah.
Sarah. There we go. All right. I'm going to go ahead and hand it off to you. Do you need me to do anything with this, or should we just leave it on? Or
No, I think I just need to share the screen, so let's do that, and then I think you're good to go. That's
okay. Awesome. Awesome. So thanks for coming, y'all. I was not joking. I literally thought there would be like 10 people, 10, 12, and there's more than 10 to 12 people. Let me yeah.
Awesome. So the presentation. I'm Sam. I'm a software engineer, as many of you are. Thanks for all coming out. And I work for a company called StepSend, and that's why the topic today is around GraphQL. We're a startup that is mainly focused around the ability to use GraphQL to source any type of platform, whether it be database, whether it be any type of API, which is also something we'll be talking about. And the topic around it is that people are using APIs more and more because people need to get data from other sources all over the place. So the conversation that I wanted to have is where we are going to be moving forward on being able to source this data and how we have all been doing it in so many different ways. And kind of the trend that we've been seeing is making it more universal so that it's all easier for us. There's so many engineers that are needed these days because we all have to do it all so differently every single time. And when we're given a task, it's like, how can I do it so different from this individual that has to have it on a different platform that I feel like I'm doing the same exact thing for? So this is just, I literally copied this on my about page. And this was kind of a little bit snippet that I gave on backends and databases and things that I thought that people constantly have to bring together. We focus entirely on GraphQL. So dive right in. JavaScript, GraphQL, and APIs. And if anyone here on questions for the group who has used GraphQL before, and who is using it right now? So 2 people. So yeah, GraphQL is really, really new, and I'm sure I'll ask the question, who's using REST APIs right now? Yeah, much more people in the room. It's much more known right now. It's been used for the past 20 years, so it's becoming much more of a challenge, and a lot of people are wondering, okay, what is this difference that we're seeing in GraphQL? Why would I want to use it? I'm so accustomed to REST APIs, and it's a thing where you don't have to use it. You can still use REST, which benefits both. But the kind of little label I have there that I'll be getting into is Open API and kind of the standardization of REST APIs to make it a lot easier. So JavaScript's third H. I took this off of a site that I thought simplified it really well, and this is JavaScript, so we're going to start off with that. Talking about all the history of JavaScript, and I'm not going to act like I was there during a lot of this, but I like to learn about it, and I am a part of some of it. So ES1, we learned about the standardization of JavaScript when we were able to finally bring together Netscape and Microsoft. And thought, oh wow, we finally bring all that together. We start to get to Ajax. We start to be able to do DOM manipulation. Oh, that's super cool. That's awesome. Chrome's like, okay, well, we have to create standards of that then to make sure that people aren't hacking everybody around the world. That is pretty much the first H. Going into the second H, now we have 2009, 2019. This is when we started to discover that we can build full-blown applications with JavaScript. That was the thing with here. Before, it was just something to make really cool functionality, and people were trying to break each other and show how cool they could be by creating functionality with HTML and CSS. Now we're able to create full-blown applications with Angular, eventually getting to Webpack compilers and being able to get an actual JavaScript modules and things like that to be able to use those throughout. Meteor tried to create a more standardized one, a more opinionated. It worked out pretty well. They're still doing okay. It's not huge. Run also jumped in. React blew up. Vue blew up. And those are the 3 that we see all over the place. And as we saw from the beginning, we really started to have that ES standard where people were able to actually use JavaScript, and that's why Node kind of blew up at that time. And Ryan Dale's the founder of Node, and it's honestly, he built that, and I'm going to talk a little bit about what he's building now. It's really cool what he's doing with that. React Native, people start to realize the value that we have to support all these different types of environments and all these different types of dependencies on ESLint and all these different compilations that we have to do on being able to support mobile applications and different OSs and IOs and everything like that. So they start to come out with that, which is why Hermes comes out later. And then we eventually had testing because we're starting to get so big that we need to be able to bring all that out and eventually improve our code because JavaScript is so dynamic in the way that we use it. And now we are in the third age, and okay, we're here now, and we have now brought up Dino. And if you realize Dino, right here, is just a respelled version of Node. Ryan Dale just reorganized the words. Dino is everything that he wanted in Node that he didn't do initially. Who has heard of Dino in the room? Yeah, awesome. So it's become a big thing. You just have to eventually bring it out because it's so standard and the community is so big in Node that it'll take like years and years eventually to change anything in that area. But Node's still great. It just has a big package of JSON that you have to use all the time, and I have a good joke for that. What's next for JS? This is just my opinion, and honestly, at some point of this, I am right because people are going to be doing this. But there's probably other things that I'm missing on here. But Collapsing layers. So I put Redwood.js on here. This is kind of for Jamstack, which is JavaScript API and markup, which is a huge community that's blowing up where you use an entire application entirely based on JavaScript. And then you're just feeding through APIs, and also you can use databases at that point, which is where Redwood comes in, or you can use things like Prisma, which is opinionating your objects, pretty much making it a little more declarative in the way you have to use it, and you have to, I haven't used Redwood in a while, but that's what Redwood does, and it has the ability to be able to pull in multiple nodes, and it's essentially a full stack Jamstack. It allows you to completely go from top to bottom, not having to use nothing else except JavaScript and APIs and databases, and then markups if you want to use those. Improving the compiler. People are realizing that now we have to be able to start using types and really establishing that everything that comes in that we want to be a string stays as a string, so that when it actually goes out and goes into the world, we know it's not going to break because someone decided to put a 10 in without putting quotes around it. So it's something as simple as that, which is really what we're going to be getting into today. Fragmentation and polyglot. So microservices, the ability to move JSON, XML, and then security and promises. I won't talk a lot about promises, but that was one of the things that Ryan Dale said he really wished he changed when he was working entirely on Node, was the ability to bring those in, because we have all been in the async await nightmare. We've done that. I hate it. It's crazy. You don't know why it's running before. You don't know why the data's not there. You just have to start all over again, and serverless has just brought that out in a wild storm, and we have no idea what's going on. So, and security. JavaScript's really dynamic, and it's really easy to do for prototyping. It's awesome for us to be able to bring things together, but it has a lot of insecurities because of that. But that's what also Dino, and I kind of put these in order. Redwood, improving the compiler. React kind of just carries all into it, and we have Polyglot working all throughout that in JSON. They essentially expect a lot of that to be moving through, and Dino kind of working it together with the security and promises. And here is the heaviest object in the universe. Nice. Okay. If you haven't seen that, then you're welcome. That's the only joke I have. What's next for JavaScript? I highlighted TypeScript. I talked about it too much, but that's essentially what we're going to be going over today, is that we need to start standardizing the types that we're moving around, and that is starting to become standardization of APIs, databases that we're using, and for us to eventually have an easier way of being able to use more opinionated and static types, so that we can actually know that if something's going to break when we have it on the internet, because it breaks a lot, especially web development all over the place. And then when I talk about that, that mostly includes improving the compiler and fragmentation and polyglot, because when we have polyglot and microservices, you're constantly moving data all around, and you're having to break it down. It's not like it's all in the single application. We know that the data has to be standardized, and we know that the data has to be in specific types. This is also argumentative, because people say, you know, I code just fine with JavaScript. I don't need TypeScript. It's not what to do. It's more not as much for you then, it's for the person that you're getting the data from. We're so big at that point that if you think that person's doing a good job, just wait until it breaks. And then we're getting into kind of why security is a big part of this. What's next for JS? And the big companies that are coming out right now, and I just put up fancy logos here for us to kind of go, wow. Netlify, Vercel, and Cloudflare. You see that those three, I mean, Cloudflare has been more of the standardization for CDN, but when you have Jamstack as a whole for JavaScript API and markup, it allows you not have to ping those servers every single time. Like Next.js, I had on the slide previous. Who has heard of Next.js? Anyone use Next.js? That's awesome. Next.js is awesome. It's essentially, it's a framework on top of React that is built for like websites. I know a lot of people like using it for websites. We host our website with it. It's hosted under, well, Vercel has it as an open source right now. But Vercel, Netlify, Cloudflare, they're all just hosting for all these different sites that want to do static Gatsby sites, that want to do server-side rendering and partial Next.js. Incremental static generation, that is also Next.js, where you want some data every single time when someone pings a page, and sometimes you know that that data is not going to be changing until we run the build again. That's kind of what that goes on with these sites. And that allows for a lot of efficiencies as well, so that we don't have to be pinging a bunch of APIs all over the place and constantly trying to get data every single time. You're going to have the data for a site and either A, breaks, or you don't get all the stuff you need. And so that comes into security, because when you have a static site that's completely static, and let's say, for example, it's a support network and you want to put the person's name up there with their unique ID, you now don't have to worry about that person getting hacked, because you're never pinging that database other than when that person already has a cache. Gatsby is a poor example that I just used right there, but that's really what it does. It enhances security because you already have everything deployed. You don't need to be asking for the data every time. It's already there. And then going along with that, improving the compiler, you know that if it gets through the build, it's probably going to be working because a lot of standardization going through that with Next.js and all that stuff. You typically using Typescript. So fragmentation and polyglot, I talked about that. That's serverless. That's serverless platforms. Love using it. You can use polyglot in more than just serverless, but I put those up there just as big names to talk about it. We'll move on. XML, JSON, it's a standard of what we're expecting to be moving through these. When we eventually want to be using polyglot, we're going to be moving data in that way through APIs. I wanted to mention that this was phase 2 of JS previous, and as you can see, there was a huge incremental spike in JSON from that point, and XML kind of dropped. So as we can see, once we found out that we can do full-scale applications with JavaScript, boom, it's gone. We realized that JSON was going to become standard. It has become standard, and I was talking earlier with some people with SOAP. It's only been around because enterprises love SOAP.
By the way, SOAP stands for Simple Object Access Protocol.
Yeah.
We were talking about
Yeah.
like what
We'll
that.
remember.
We'll remember.
Simple object access protocol. I brought this up again just as a reminder in case we wanted to see another illustration. 2009, Node came out, PS5.
What's the color coding? Are you sure about it?
Yeah, I didn't look into it that much. ES1, so the standardization of JavaScript, all the frameworks that came into it, and then the compilers, and then
Okay.
environments. Thank you. Yeah. Boom. I love this. I thought it was super cool. So you can take that right there. Latest metric. It's where I got a lot of my notes today. Why am I talking so much about then and now JavaScript? Because the next wave of JavaScript is the expansive movement of frameworks handling the inconceivable amount of data, specifically JSON flowing through it, statically and opinionated. Yep. API ecosystem is drastically growing. It's building better digital experience and products. That was what I talked on there. Apogee, customers increased 46% year over year to 2.2 trillion calls between 2019 and 2020. That's insane. That's insane. So 46% growth. So what is static typing? I'm going to start doing some live coding for you guys up here to kind of show what's going on with it. So static typing is when the compiler enforces values of the same type. Here's an example of how it would work in JavaScript. Let value equals 5, value now equals hello as a string. That works. Here's the type value changes from number to string in TypeScript. This doesn't work. Error type, and I should have changed the color on here. Error type, hello is not assignable to that number. I can play around with it right now, but I think for time and how much I'm talking right now, I will just let you know that this does work. You can do this on that environment. TypeScript will not allow that to build. So if you're in npm build in your JavaScript environment, boom, that does not work. That won't go through. If you were to go to your browser right now and you were to type this exactly into your console and press enter, you would get hello in return. And that shouldn't have been allowed because your value used to be 5. And I don't want hello to be the value that I get in return for how much I should pay you. So getting into more of the specific layers of APIs that I was talking about earlier. GraphQL, open API, and it's a TypeScript tree. It really is. So when you're a TypeScript developer and you want to be able to have standardization of the data coming through, a lot of the breaking that goes on in TypeScript, as you may see, actually occurs because the data is coming in different. So if you have standards throughout your TypeScript and your JavaScript application, you say this can never be a different type. I always want this to be true, false. I want this to be true, true, or false. I can't be anything else. Sometimes your API might send you something completely different and it breaks. And that's on build, right? So that's just in the build environment that's if you're testing it correctly. Sometimes they'll just send it on an actual moment and it'll break. But TypeScript allows for you to be able to standardize that through our site so you know if that's going to break. You say, hey, something's going on your end. But with GraphQL, especially, and the open API spec of knowing exactly what types are coming from your APIs, it's a dream. It's a dream come true. It's a match made in heaven, and I'm going to tell you why. So kind of getting into these, I'm going to start going to links to show what's going on here. Let's see if I can post it. Okay. Let's go right here. So API design patterns and best practices. So HTTP methods is what we're talking about here. And specifically right here, we're talking about REST APIs. REST APIs come in all different facets and all different forms. There's so many different ways that I've seen APIs at this point. It drives me insane. And the amount that we talk about every single day on how we're going to actually just make it into GraphQL is so drastic. And we have to find standards throughout. It's really hard, and we have to just find the most common patterns. But kind of just talking about it is get versus post, what we see as the two most standard practices, and then everything that comes into editing on post post, put, patch, response post, and then really the complicated parts is where people are not deciding if they actually want to envelop data by putting a unique key, a unique object value there to be able to describe what is coming in at that point, or just bringing it in general. It's as simple as that. That causes a lot of headache for people to be able to understand how they should actually get the data beneath it and be able to move it through. So that's a very simple one. And then the biggest one that drives a lot of headache for people when they actually are JavaScript developers, I'm sure I could probably do a couple people pointed out here, is pagination. The amount of different ways that you can decide how you want to get the next page. So sometimes they'll actually bring it to you, let's say as a variable in the actual field and say, this does have more. Yes, that could be a value. It has more, true. And then you can have, and here's the next page. Here's the unique parameter that you now need to inject in your next page. And make 60 calls to all these different HTTP method endpoints and make sure that none of them crash. So you can all 6 pages, all of them. Or they can provide it in different ways, and there's many different ways. That's the one I see when I usually do my practices a lot. And that's the one that we'll be using an example today at HubSpot that does that. And then you, of course, and then they talked about briefly about GraphQL here. So getting away from that one, we have Swagger.io. So now I'm getting into the standardization of, and we won't be here long. You don't have to read into this, don't worry about it. It's just kind of showing you an overlay of what's going on. So this is the standardization of Rest API. And what it is called is Open API. In 2016, they became Open API. They used to be Swagger API. And now SmartBear actually takes Swagger and they allow and help, and they will actually get you to pay them if you really, really want to do this in some facets and some capacities, especially for enterprise. So you have your post parameters. An example here is this is exactly what you're going to be posting. And this is the very large XML standard that Swagger provides by saying, okay, here's the info, here's the description. And this is essentially what we'll take and we'll transcribe it in GraphQL. The battery looks like it's low. Thank you.
I might want to plug in.
Is it charged? Yeah, this one isn't charged. Yes. Wait, I might have one. I don't charge it. Yeah, red bags are really. See, mine displays and charges. So let's see. So that's Swagger, and right there you can see that there's a path coming in. No, I don't have one. Oh, yeah. Right. I got one. And what you can see there is it pretty much provides the description of the entire API, how it's coming in, all the individual paths that come in, and how it's actually going to produce that individual material, application JSON, XML, things like that, what you'll see as a standardization. Okay, cool. Hopefully we'll die still. And won't talk about it anymore, just list all the individual fields, exactly what they can be. This is how they describe the types in Swagger. And that's why we like Swagger so much.
So is this compiled from your code, or you have to actually do it?
Compiled from your code. So this is as if you're building out a REST API.
Yeah. Swagger is just documentation.
Swagger is a documentation for your API, yes. And it's a way of, so if I wanted to come over and I wanted to, and that's exactly what I was going to come to was.
You could actually build it from JS.
JS. What?
You can build Swagger documentation from JS.
Did not know. Very cool. I'm done. I like when I get to use it because people provide it to me. This is an example of one that I used. It was Uptrends. It does monitoring of your site. And as you said earlier, it's a documentation. I was able to take the documentation of that and they provided it in the same exact manner, and then I'm able to transcribe it into GraphQL. It's a super easy standard that I'm able to use, and it works interchangeably. So if I wanted to be able to have it graphicized, I forgot how to say that, into GraphQL, it's very easy to do. It's become a standard on REST. And if I were to want to use this, I know that that's what I would be expecting as a pretty set forward standard on what I want to get. If two totally different companies have Swagger documentation on their APIs, I know that the APIs are going to be very, very similar in what they present.
Just to add to that, what Swagger actually is something called a codec. It's essentially a standard format by which you can use other tools to kind of build your adapters. You call those like service agents. And so a lot of enterprise companies like Swagger and pay for Swagger specifically because they can just chuck it into some kind of CLI tool, and it's just going to basically do half the work for them, and they just really just call a bunch of functions at the end of the day.
So I think that's all I'm going to show for now. Typescript, here we go. Here's the little environment that I pulled up. You can see here, if you run that, you should get the error. Yeah, error comes back. String is not assignable to type number. So that's what you see. But if you were to change that or declare the variable at a different point, so you can play around with this as well. But getting back over, let's see. Awesome. Okay, so I created a task. Get conversion events of a contact in a company by domain. So I want someone on my site to be able to, or in my product software, to be able to search a company and see the conversion events of the specific content of that person in that company. Step one, you have to post to search for a company, get type ID, result root, company ID. I won't show it, I won't go through these, but you'll get a REST API response, and if we have time, I'll go back through these later, but I always end up putting too much and then I talk for too long. So step two, you have to then get from that, because now we were able to get type ID from that company ID that we went down the result route and we were able to go get that. Get search contacts in company, get type ID, contacts, identity, fit. So now we're able to go into this endpoint, get company contacts, right? So now we search for the company, we're able to find all the companies, and they could provide more than one. Now we have to get the company contacts of all those companies that are provided. So we have to then run a map, right, in a serverless function to be able to then tie all those together and bring this in and map the new array with type string. So now we have all the individual contacts from that all tied into a string that we are now waiting to be able to do for one last call, get that batch of contacts by bid, and then we pass in that unique string properties, and then we're able to see those conversion events. So we had to ping 3 times on a REST API to be able to then do this task, right? So the biggest thing here that I will highlight it that you should notice is that the type ID was not an ID the entire time, right? So we went from type ID initially, and we brought it down, and then it was a type ID, and then we had to inject it as a string later on, so that we're able to then get that unique ID string to actually inject into this endpoint, so that we can then get all those IDs, because the way we had to do the search to actually get those injected into that REST API, the last one, we had to change the type to a string. And that's a perfect example of, okay, I could create a standardization of knowing that my data is going to be okay, but sometimes they give you the wrong data, and you have to change it yourself in order to get the search that you want. And this is all happening within one API. This is all HubSpot. This is all HubSpot, and they can change the types and when you're going to get the response. And that'll happen in many APIs all over the place, but that's a perfect example of why you don't want to create the type standardization so that you don't have to worry about that when you want to be able to do all these different REST API searches and be able to get that task done. Any questions?
So compared to GraphQL, like if we just make one search, then we'll be done.
So there you go. That's one example. Yeah, I put this into my VS Code, and then I screenshotted it, so I wouldn't have to code it for you. So if you were to go in and you wanted to fetch that, I put up a fun little URL because I didn't know what that's coming from, learn/GraphQL. We're going to post it every time. If we have an authorization, we're going to need it. It's application JSON. We're going to then do it and change it up here because I took this code from a different example that we're eventually going to go to. But that's essentially what you do. You would then have this query right in here, and I didn't do exactly that. I changed it, I don't think I had time. But you would do, if you were to do that tree, let me see if you can make it up right now. I won't show you the exact difference. But you would do in that one, it would be, what did we have? We had search, so it then would be search contacts, and then it would come here, and it would be, you would have the actual domain, you search it as a string, and then out of that, it would have contacts, and then you'd have you'd have companies, and then under that would be another substruct of the abstract structure tree that we're going to be talking about. You would have companies, contacts, and then you would just be able to get that exact point right here. Now you need conversion events. You can rename that if you want. That's what we do. But that's what it would be. It would be search the companies. Then you have the actual domain search that you have here. Then it would be all the companies that you would list. You can get the IDs, whatever else you would want from that individual one you can have in that tree. And then in that subsector, we would have a subarray of all the contacts within that, and then you'd be able to list those out. And I have been transcribing that, and it has been insane. But it is doable. I did it. I hated it. Yeah.
So on the server side, like on the implementation side, you see like this, you make, I guess, a big graph of like things that you can do, and then you implement them. and then whatever you query is just kind of like a subset of that, basically.
Yep, it's a subset, it's a sub-object, subarray. It's usually what it's going to be, but it all works into the graph concept of being able to have an abstract tree where you can go to any individual point and get what you want out of it, to be able to see those things. And I'll do another example right here of kind of how that can work with the Rick and Morty GraphQL API. So we're going to come into here, and this is GraphQL bin. There's a bunch of these online. But if I were to go into GraphQL Explorer, this is what you would be able to see, and this is how you play. Yeah.
Sorry, maybe a little bigger. Or like switch some light mode so that it's readable.
Good.
Yeah, that's good.
If you could click the settings button on the top right, maybe there's a light mode because we need better contrast if possible. There's a little gear above down the download. Above download, there's a little gear. Top right of the page, like not the browser, but just the page. Lower.
Oh,
There you
there.
go. You did. Yes.
Couldn't see it because it's dark.
Okay, and then.
Oh, edit the light windows box.
Yes.
Save settings.
Save.
Hey! Colorblind, I guess. Yeah, right. Okay, so awesome. So here is Rick and Morty API.com/GraphQL. So you asked this earlier, we're hitting one endpoint the entire time. GraphQL. You're not doing anything else except hitting one individual endpoint. If you were to add HTTP headers in here, this is where you would do it, and you would just go in here and you'd be like authorization, and you put like quotes around those, and then you go like bear yada like that, and that's how it's done. And then we just add this one right here, and that's how you would add that. But we'll ignore that because it throws me there.
Could you do more than one query at the same time?
Yeah, absolutely. You can do if you were to do this, and then I were to name it something else, and then go query get characters too. It would then ask me, I think, previous.
Oh, so the query name is like just arbitrary. It's just whatever you want.
Yep.
Oh, that's cool. Okay.
Yeah. So you're just naming it, and the only two things you can do here is query and mutation. It's only two things. You can't do anything else. It's all going to be post actions. Mutation is post in the REST API world. Query is get.
Is it closer to post or put parlance, if you know?
Yes.
I don't know about the I don't know about the HTTP method on like what it's actually passing on, like the actual like they're all pull requests. They're all what? They're all what?
They're all put.
No, they're all it's all post. Yeah.
Well, I mean, yeah, they're post because like that's how it's communicated. But like, is it more equivalent to a traditional post or traditional put?
I think creating and editing are both done by mutators, right?
Creating and editing are both the CRUD operations all done through you said post.
Through mutators.
Mutators, yes. Creating, writing, anything that's writing is going through mutations. Yeah.
Okay.
And getting is all done through chords.
Perfect.
So you said we can have two queries in one basically. How do we use it like on a follow line? Because if you try to do it 2 times, then it will say, oh, you've already instantiated data already. Already.
Yeah, it's probably an Apollo standard at that point because if you were to do fetch, it would work, right? Like if you were to do straight fetch, like what I did over here, it would probably work. It would give you both of those from that endpoint. But Apollo is probably going, hey, you don't need to do this twice. They're probably throwing you like a Typescript error kind of thing, where they're like, hey, do you need to do this twice? And then if not, what you can do is you can just differentiate those and have 2 separate calls. They probably want you to name them 2 different queries outside of the actual query name. So you can't do it here. It would probably be like in that Apollo client, somewhere up here it'd be like Apollo dot query name dot, and then you have to name it something else. It's probably something like that. You just have to name that one above and only have 1 query inside. It's probably how they want you to do it, so you don't break that.
What did it return if you said did like 2 of these, right? Is it like 2 objects of which like one is called like get characters or something, and then it has like the data that you asked for, or are they like merged? Because I noticed like both of them are characters.
I don't know why I told you that. I totally franked. It's as simple as this. I literally just said it's making me do one or the other. I'm sorry. I totally messed it up. It's making me do one or the other. So you have to do one query at a time, sorry. But you can do them separately, right? You can have probably 2 individual ones and 2 different components, maybe. I can't say for certain, I think I have. You probably can. I mean, if you need different component to pull up all the news articles in a page, and you need another one to pull up all the users that have recently liked an individual one, I'd be very surprised if we couldn't get some capacity.
Could you shrink that down so we could see what's on the right-hand side? Is that the return data?
Yeah, I'll move this. So this is the schema. So right here, so this is the return data. So let's run it. Boom. So I should have cached it, but not cached it, so you'd actually see it and do the whole thing. But that's the data that's coming back. So it always comes in data format, and then you have characters, and you have results coming in. And then inside of here, it doesn't, the biggest thing about GraphQL too is you don't ever write it like this. Never gonna be like that. It's always gonna be this. And that's actually a pet peeve that people have with it, is they don't know if it's gonna be coming in as an array or if it's gonna be coming in as an individual object. It's always object written, because that's just how the abstract tree of GraphQL works, because that's exactly what you're telling them what you need. But the array and how it is displayed can be still shown in that way. They'll return it as an array the exact same way as you would see it in.
So at the end of the day, what you're giving it is basically like, hey, here's the fields I actually care about, so don't send me anything else.
Yeah, if I were to get rid of, so each individual one, it comes in with name, ID, image. So if you were to remove image, you wouldn't get it.
Gotcha.
It's just like that.
Okay.
And so yeah,
Is that its primary benefit, or is that like, is there more to that?
there's more to it. So now let's say you want to take control of your API, right? So I want names suddenly for some reason in Rick and Morty, and I have an example to do this one as well. So I created one here, and so all I did was I took this schema right here. So it's a standardization, same way as OpenAPI has the standardization of their specs. You have type coming in, and then you have character and characters, and then you have all the individual ones that are coming underneath it as subarrays, and you have episode, and then you have under here location. And so I just pulled all these in previous. So you have character, episode, location, info, and I have a core example here that I already had up and running. But what I have is all I'm using, and this is what we do at step 1. So we take at GraphQL, it's called the directives, and those are standards in step 7. It allows you to create custom functions that actually can behave in GraphQL. You can also write resolvers alongside of them, which we won't get into. But you can have characters, and then pulls it in just as that, and then we have that endpoint, the same exact one we got there. No authorization to be able to get into it. And as you can see, we have characters, and then that results name is going to pull in all the individual characters of that type. So as you can see here, we have name string, right? So this is where types come in, where types is super important. GraphQL, also with JavaScript and Typescript, things like that. You will see.
A little bigger.
Yep. Let's do that. So
Actually, light mode would be good again for this.
that's a big ask.
Command Shift P. Command Shift P.
Command Shift P.
And then type theme.
Type
Theme.
yeah.
THE. Reference the color theme. There you go. Like that. Pick a light one.
There we go. Oh, never gonna get it back. No, I'm like just kidding.
Excellent.
You find it. Yeah. So as you can see, we have every single standard here. And if we were running right now, and this is just our CLI that we run when we want to be able to do this kind of stuff. All we do having going alongside it is fig.yaml in case you want to put authorization piece in, and then we have an index that understands where it's coming from. But we're deploying an endpoint right now, just with the info we have here. So we're building an API just with the info we have displayed right here. And so we have that coming in, and we can see pretty much the same exact thing as a graphical explorer, characters, results,
Oh, nice.
ID, we got it. So we know the data's coming in, and we can click everything. We can go origin, location, episode, and it'll fill everything in. Sometimes it only does ID. It's kind of dependent on the API, from what I've noticed right now. But as you can see, it pulls in everything. Every single episode has an array. So the biggest thing here is now you notice that name is string. And if we name it integer, but we don't declare it as required, so we don't do that, and we save it as this, I actually saved it twice, but it's not required, and so I'm showing the example of name right here. So I was going to do that right after. Conflict content has changed now. Just run it again. integer.
Where's the actual data coming from? Like, is this like implemented or?
This is Rick and Morty API. So it's the same exact thing. So if I were to go to this, it's as if you're hitting a REST API endpoint, just coming from that endpoint, rickandmorty.com. That's what I'm hitting.
So essentially, you took the schema from that Rick and Morty API, and then you're sending it to the company that you work with.
Yeah, we're just creating a layer on it right now to show how we can manipulate the schema, right? Because they provide us the schema, so GraphQL is as if it's open. It's open. You can see everything as well as if I were to go to that swagger.json of the REST API. I came over here, and when I went to that, when I went to this right here, the GraphQL bin, I mean, they are giving me the entire schema of what I'm querying from them. They're saying, here's the stuff you can query. You can just inject and control copy A, all this, and put it all, I need to put it over here. So that good stuff. Put it all right here, and you have, it's essentially the same exact thing. It's all using the graphical explorer as if you're using Postman, right?
Mm.
And we're just creating a layer real quick of our own REST API right now in our own language graph.
Can I add to that? You can actually plug and play almost any database into GraphQL, and it will do the translation. Get the question. It's very good.
So there's no
Very good.
performance loss, like NoSQL versus SQL.
You still run into those hiccups if you don't set up your models correctly.
So you need an SOA or something.
Yes and no.
You said an SOA?
Service oriented architecture, like that.
Yeah.
Last time.
Yeah, it's
So what we can do for an SOA is actually, you would plug this on top of your SOA. Or
This
SOA.
would work.
Yeah, if you want to optimize the call, you can easily just.
all business logic is done inside of it. It's all just a layer right on top that you want to be able to write it to. Yeah, that helps.
It comes with an ORM. That like is magic.
So you can write resolvers going alongside of it. I know Apollo supports that as well if you want to manipulate data from coming from a database, for example. So you can actually write logic alongside of it, or you can have it handled outside of it as well. But it does have latency if you run resolvers, obviously. But performance is where we will have a second session of that for sure. That's always really interesting. Yeah, so cool though, yeah. But did I answer your question?
Yeah, yes, thank you.
Do people tend to use GraphQL like raw, like where they're just using GraphQL itself, or do they tend to use it to facilitate, like, you know what an ORM is?
Yes.
So do people gravitate towards ORMs to do the actual queries for them, and then GraphQL is like the underlying language? Like, for instance, like you could have a database and you have SQL, right? You could write SQL yourself, or you use like some library, it's called an ORM, and it just kind of does it for you with all those little model classes and stuff.
Yes.
So
Go ahead.
what's more typical?
Yeah, no, this might actually help your question too. Like Redwood.js is a really good example of that, where they use an ORM. I talked about Prisma earlier. Prisma is the ORM to their full stack development process. So if you want to pull from a database on their endpoint, use the Prisma ORM to be able to then do that full stack development process. That then does, I think that's object relational management. Yeah,
Yeah, it is. Yeah.
And they allow Prisma essentially handles all that. And I don't know latency on that, but that's a flow that works with it, which then they use GraphQL to send all those.
But the big O for that is like graph, like a B trade or something versus like a C-scared SQL query. You're looking at like.
Yeah, you already got to the performance problem that you can shoot yourself in the foot by asking for too much data across multiple different tables, and it just freezes. What you can do is you can write the queries directly and then import them into the GQL and return that as a type,
But that doesn't solve the. So it's a tree versus like that.
well, if you can write the query yourself, right, and then you can make the optimizations there and tell.
What we do on our end, so yeah, what we do on our end, and I don't know where I had that. Oh, this is my code. I don't even know what I'm looking at anymore. In here, you can actually write an app.db query, for example. That's what we do right here. So you do app.db query, and then you can write your SQL query right there that you need, and then or whatever SQL. I haven't worked with databases as closely as I have. But you can write whatever you need through your DB query and select all. You can do exactly that right then, and then it'll be able to pull that data in. And then it just has to match up with the types, and then be able to display it in GraphQL. So getting back into this, so we changed name to integer. So now name is going to be pulled, but if everything works, we should see name results. Oh, I have episode coming before created, but if you come down, I'll just remove this. Distractions. So null. So you can see that the data didn't come in, but it still passed. It just brought us null. So now we have no data, and we're like, okay, where's our name? So, but if we require it, and then we do the same exact thing, as you can see, episode, you are required to use and have episode if you ever query it. So it asks for that individual one as well as an array. But now if we do it, we get null for everything. And it says, no, you have no results, and you actually get an error message and cannot return null for non-null field character.name. So that's how it works in GraphQL right there, is if you require it in your schema, and we're writing this API and we say, if you want to ask for this stuff, name has to come with it. And if name doesn't come, then we're going to throw you an error and say, no, we aren't going to get that stuff. But it's all optional. Everything's optional in this TypeScript language. You can, it's typed in that way. And that's kind of how type works through GraphQL as an example.
You have to implement that yourself. Like when you're actually like writing a server function that like does whatever, like is GraphQL a layer on top of you actually writing that stuff? Like where you return objects? I mean, I don't know. But like where does GraphQL meet actual implementation? Like to write a function that returns some data.
So this is showing mostly the client side.
Okay.
There's a server side of it too, where you have to implement what object, like you tell, like the server is basically saying these are the objects that are available and these are the attributes that I can give you for these objects. And you're writing that. So you could be on a Rails app, you have like a GraphQL gem that lives on top of active record. So you write all your GraphQL stuff that then goes to active record to fetch the actual data from the database. And then the GraphQL client can then say, or can then get the schema so that it's like, okay, these are the things that are available to me from the server, and these are the attributes, and I just want this, this, and this.
Got it. But like that being said, is GraphQL like in practice, like when you're actually working with it, is it equivalent to like say something like Express, where you know how you make an Express instance and you say like
it would be
post
equivalent
this?
to writing a JSON and
But it's mostly up to the server developer to actually do that correctly.
yeah.
Okay.
Yeah, and just to second that, this is, so we have, as an example over here, where like we have a query going on. I just gotta stop looking at this. Type book, type query, right? So as we wrote it out and what we're seeing when we actually have that schema and how it's defined right there. It then has the field names and parent args, context info. It's kind of how it passes when it actually wants to be able to interpret what's going to be brought to the server and to be able to get that data. And you have the parent, so the top level, right? So what's actually at the top of the tree, as you would like to say in a REST API standard. You have that as the top resolver and to be able to say, okay, this is where we're going to start with, and now we're going to go chase everything else. Next thing we look for is arguments. So say we want book, and for this example, we don't have an argument, there's none there, but say that required an ID for an individual book at a later point, and we wanted to be able to query book ID, and it's an ID type, and then we wanted an individual book, right? So if we were to just add one more to that query there, then it would have an argument that's passed to the field, so now it knows what it needs to be looking for in that specific type that it's going to be finding in that database, right? And however you write that database, that's how it's going to pass that argument in. Then you have the context, authorization, things like that, data structures that's going to be looking for. And then the info is the information about the schema, the query, and the execution state of the operation. So everything else that's going on with what it's actually looking for title, author, and the types that are going to be brought in with it alongside that path. But the path is there sometimes the info is always going to be the same there. You're going to be just looking for those fields that are presented in sub-objects that are presented to that initial parent. And that in abstract syntax tree, so instead of a tree that behaves like this, you have an abstract tree that's behaving like this. right? So 2 can go to 5. And they don't have 1 here, but 4 can go to 2, and so on and so forth. And it's abstract in its way, and I kept it small there. But that's what's happening. And if you're to come over to GraphQL Voyager here, it gives an example on a really massive scale of what could be happening with your tree. So, that's an example of all the films, and you can see that the film, you guys can't see any of this, but films and everything like that come around, and that's just on a larger scale. So I kept it small so that we could see what we're working on. But that's essentially what's happening there. And then, as I said, you have the sample abstract that's being pulled in, and that's actually the syntax tree that it's looking for, similar to the swagger.json, of what it needs to know to pull. But that's more of a documentation, as someone said earlier, but it follows a similar syntax on what it does for what it wants to see. So kind, value, author, then you have title, and then you have book coming in as that parent right there. And then you have definitions and directives, if you need any of those, to come in with the arguments that may be presented. They pass those arguments down to each individual one as it goes. So if it's looking for one, it knows that every single one, we only need one. And then it just says, okay, we just need these fields because we're posting. So it allows you to be able to differentiate that stuff. So
Schemas are defined by the server, right?
schema is different from a server, but the server is hosting the schema.
Got it. Okay.
Tree versus graph, we've talked enough about it, but yeah, we don't really need to dive any more complex in a graph. Two major types, directed and undirected graphs. Like a network, there can be loops. There's no, now this is what we've been talking about, there's no root node on graph. There is a root node in the tree, right? So it all starts at the top. That's why we have to make 3 different calls, because we work all the way down our tree. We can't go back out and check other things out. We have to actually now start over at a different endpoint that we're currently navigating to get the data. So the abstraction that consists of a group of vertices connected provisions. You saw it. So that's essentially the top. It's just showing that. It's just explaining that that's a visual of it. And we've been talking about the abstract syntax tree. Steven Snyder puts it, the GraphQL abstract syntax tree, dawn of a schema. ASC is just a fancy way of saying heavily nested objects. So it's the ability to just nest objects and then go retrieve them in the same abstract layer that we have, where anything can go to anywhere at any point. And really, the dawn of the schema part is saying we can do that because we provide a schema early on, so that when we post, we know what we're going to be getting. And we're saying, here's the schema that you provided, or that we're providing you. Come and get the data that you want. We have it all tied together in heavily nested objects. And does not return too much data, as everyone says with REST, it's too chatty. You have the SDL, which is actually the schema definition language. So what we were in earlier, where we changed the name from string to integer, we actually were in our SDL right there. And that also improves when we have a schema on introspection. As I was saying, I was able to use uptrends and be able to translate it and be able to pull Rick and Morty's, for example. I was easily able to introspect that because there's a standard schema that everyone can just then put into their own and use on their own, rather than only getting a response and somehow being like, hey, I have a response and the data that came from it, but I want to know initially what got this data. Well, we're able to provide that because of through schema. And as I said earlier, the standards are similar to the Open API, and that's why types become really important for JavaScript, and it helps with that standardization. And just talking about how when you're actually querying those, it follows the same pattern. So now we're actually querying books, title, author from the initial types that we declared. And as here we don't have an argument, we can see the parent to the context of none. There's no args in context in this one. They give that, but then the info provided one. And that's it.
Done. Everyone give it up again for Sam. You want Sam or Sam?
Sam.
Sam.
Awesome. Yeah, questions?
Yeah.
Floor's open.
So just being here, I kind of caught a vision of the future where like everything is JavaScript type, like everything's standardized. Do you see that, like something like that?
I mean, you can write GraphQL in Go. So you can write it and go to graphql.org and you can see all the different ways that you can write a server and host a schema. You can host it in all these different backend languages, but JSON, as we saw, like standardized the way we're able to actually get data and provide it, and JavaScript generally takes that kind of stuff and is able to handle it. So I'd say for front end, JavaScript really does handle a lot of that and makes it really, really easy. And GraphQL makes it a lot easier for JavaScript developers, right? You can't get JSON in a lot of other manners as well as you can in JavaScript. And so the community is all JavaScript everything when it comes to React. All the languages are built on it with those frameworks on top, like Next, Gatsby. They all love it. Cool. So yeah, I would say like I love it, and like GraphQL goes hand in hand with JavaScript. So GraphQL wins JavaScript. But you can always put that into it. Some stuff's fast, right? Like Node's not too efficient, but Dino's going to so.
Naive question, what's the pros of TypeScript? Why not just explicitly check type needed?
What's the point of TypeScript? If you could just do it in JavaScript?
Yeah, just check why don't you just check the type it's necessary.
Yeah,
You'll know it's
that's
wrong.
right.
You'll know it's wrong before you run it.
Well, like, so for a one-person job, not a big deal, right? Multiply it by 200, right? So all of a sudden, you're working with a team of 20, and then another team of 10 that's working on their own separate APIs. They send you like a data pack, and they're like, okay, students what, right? Is it like an array? Is it enums? Are they strings? Right? And then it's one of those things that if you don't put in the right thing or the wrong type, it might not crash immediately. But then because JavaScript has that weird coercion rule, right, and everything can be treated or falsy, the weirdest errors will show up, and it'll take like way too long to figure out what's the wrong thing. So the idea is that by them yelling at you right off the bat, you're not paying for it later, which is nuts, right? Because it's like, why would you want to work on something where they already yell at you? That's the way
No, absolutely. I mean, you said enums too, and like enums are a standard in GraphQL all the time. So like people use enums all the time, and it's essentially saying we specifically need this stuff rather than just a specific type. We need it to actually be an individual object to see this as well. It can be multiple objects, it's or statements, and then but that just adds complexity to the layer of like. Luckily, you have a schema, right, from GraphQL to be able to be like, oh, now I can see all the enums that can possibly come in for it. But
like the string of false is actually truthy, right? So if you try to convert like the word false, it's true, right? So it's like that's just typically accurate.
My question, so meaning that there are no super movements. What is the problem that you have to why did the adoption is not there yet? Like why are companies doing less if GraphQL provides a little more?
or so, yeah. SOAP is actually really secure, which is fine. So, which bringing up of course enterprise is a secure thing, but that's why they all use that. But REST has just been standard. It's been 20 years, right? So REST has been standard for the past 20 years in GraphQL. Like the biggest thing is you have like you said, a team 200 working on an individual platform. Oh, hey, I'm coming in today, and I'm going to go, hey, I like GraphQL. You're going to shut up. You don't want to do that right now. And a lot of schools don't teach it right now too because it's just so new. It really has just become a standard in open source since like 2015, which is a long time. It's 6 years, but really that's right around.
I think I phrased my question wrong. Like my original question was, what problems did you see in GraphQL at scale? Like, why did GraphQL start?
Yeah.
Does it? Like, at scale?
It has its, you can type in why, there's people who have written articles on like why I stick with REST, right? Like there's at some point when you have GraphQL, what's the biggest reasons as to what GraphQL does not provide?
Caching.
Yeah, I was about to say cache was cache, but at the same time it has its own like because you're posting, right? Because it just works on HTTP methods, they're so different, and for REST that it's made it a standard on what it can cache and what it cannot. But when it comes to only posting every time, cache is a huge one. We've been talking about that too. That's a good one. But there's a bunch.
That's just a tough, right? You use the top, you have to see it, GraphQL over anything.
Yeah, you can use GraphQL on top of any layer, but then you're adding a layer, right? So it's like if the API doesn't support GraphQL, you're stuck with REST, right? And if you create a layer, then you got complexities and inefficiencies and all that stuff.
The overhead of GraphQL is actually implementing it on the server. Because it's not just like you have your active record or your ORM or whatever that grabs your data and you can send it off as JSON. That's easy. But then you implement GraphQL, which does like all the magic of letting the client pick and choose what data it wants and how it's paginated and stuff like that. That takes time to implement. So yeah. Well, it really depends. But that overhead is offset by if you have many different clients, like the original GraphQL came from Facebook. They have the web app, they have iPad, they have iOS, phones, and each one of those different clients requires different amounts of data. So if you were to get your profile, for example, the phone can't display as much as a giant screen. So when a phone makes a request to their GraphQL API, it'll only get, I'll just get your name and whatever, like a small amount of things that I can display on that small screen. But when you go to Facebook.com on your desktop, the GraphQL client on the web app will say, give me everything. That's where it's offset, because now on the server side, the developers are only writing the GraphQL stuff once, instead of if you were to try to do that with JSON API, you would have to write multiple endpoints.
So that said, let's say you're making a full stack app.
Yeah.
Is GraphQL running on the assumption that you have the type of complexity to, justify it, right? Where you might not want to use GraphQL if you're just making like an alarm clock app or something super simple. It's really if you're making something that's multimodal, really intense.
That's where it becomes, let's scale up. You have to be very careful with, especially associations, like model associations. With, like, if you have your user and you have, this user's posts, and then the post's comments, if you allow like certain types of queries, you could end up in performance hell.
Like working my company, they.
It's like
That happens regardless, even like JSON serializers, it's the back end side. So it's like, I don't see what.
But with the JSON API, your queries are very static.
And that's, I think that's my question, actually. So do you work mainly on like front-end development or back-end development?
I'm front end, so I'm like a developer advocate, pretty much. I work a lot with people having front end examples that they need, and we work with them to say like, here's how you can use GraphQL in the front end project, but they can build out schema. So we allow you to build it's like a layer, right? So you can build out your own API endpoint on whatever other REST endpoints or GraphQL or database endpoints that you want, and combine your data. Really, the best thing about steps in GraphQL that we provide is stitching your data however you want. It's an abstract tree, so you can bring your data together however you want. Really, you just need I'm sure if you've used a database like Datorama I've used in the past, where all you need is the ID. You need something that ties an email, something that ties to another list of books. You need the author. You can tie that to a completely other data source as long as you have that unique identifier. Yeah, so you just bring it together. So it's like, oh, cool. If we feel like email, 98% of the time, email provides a standard. Like we know that email there is going to match the email here and provide us the data we need from these two different sources. And we combine them through GraphQL.
I think that's what I'm curious on. So I'm a back-end developer, and I'm curious on really what the back-end implementation looks like for
Yeah, thank
Okay, yeah, great. Yeah, schema, so everything's like this perfect token world. But to get that, I'm curious on what that looks like. And I'm actually having a hard time kind of understanding how the queries are constructed on the front end. I see, like,
one of the
so-
slide had an example for the race.
Oh, the queries?
Yeah, it was like context, tags in some of those.
Yeah,
It
there's,
almost seems like you have a data, it's almost like a front end database that's being.
if you look for Apollo
This is
Odyssey,
the next slide. This is the next slide.
In the same way that you're writing,
There you go.
Jason, you're writing the schema for the GraphQL like interface. That will also have the code for fetching that data.
So you have like 3 different things that you normally do, just to get.
Hi guys, I'm Chris. If you came in a little later, can you sign up for and do your COVID waiver for us?
So guys, if you have not clicked on that link, if you came late, I need you guys to take a photo of this QR code and fill out the form.
Yep.
It's a COVID release form. It's also for contact tracing. Of course, nothing's gonna happen, but just in case, it's also a liability thing, so we appreciate it if you. Hey, if anyone has like questions or wants to like contact you and follow up, what's the best way to do so?
yeah, I now do a Twitter, so you can do.
Are you on the Slack?
Are you on the Slack?
Yeah, it's
I'm on the Slack. You can see me right here.
Sweet.
I thought this was
There
funny.
he is.
So there we go.
What in Sand Hill is this?
Yeah, self-proclaimed dancer. I love dancing. My buddy was a professional dancer that I grew up with, so I've taken some of his traits, not all of them. And then yeah, that's me. So Samuel Garrett H. G-A-R.
Sweet.
Awesome.
I'll put it in the front of my name too.
Awesome.
Yeah.
Awesome. You guys, everyone give it up for Fun fact, you just moved here like 3 weeks ago, right?
Yeah.
So really